Thank you, Sergey. Thank you for allowing me to present at LangSec remotely. And hello, everybody. Welcome to my presentation, Lua Code, Security Overview, and Practical Approaches to Static Analysis. My name is Andrei Kostin, and I'm currently with University of Jyväskylä in Finland. For today's presentation, I'm proposing I'll do a short introduction about Lua and some of the current limitations in security analysis. We'll present shortly our contributions with this research work, research paper. We'll go into some details, small details of implementation examples and results, and we'll conclude, and I'll be ready for a Q&A session. So what is Lua? Lua is interpreted dynamic language proposed and implemented by Jerusalimsky et al. By Pontifical Catholic University of Rio in '96. It is an interpreted cross-platform, embeddable, performant, and very low footprint language. And according to its authors, it supports extensible semantics and anonymous functions and proper tail calls and coroutines, which is a particularity of this language. And there are many very good resources on Lua language, including linting and analysis of Lua code on and other language aspects in the following curated list. And the idea behind this research work is that we have seen as part of the beginning of this work is that Lua's popularity is on the rise, even though it's not on the top of the charts, but its popularity is rising. So according to TOB index in May 2017, it's the 27th most popular language. And to give it more context, it is basically par or above in this chart with Transactx, SQL, Lisp, Ada, Scala, Erlang, and Bash, which are pretty well-known languages. And according to PYPL index, it is the 90th most popular in May 2017. And again, a little bit of context, it is par or above with Go, Delphi, and Haskell. So we can see that it is going basically neck to neck with other very popular languages used in various other contexts of programming. And a little bit of numbers about Lua, not just context information. Well, PHP is also a dynamic and interpreted language, and it is still one of the most used languages in web technologies. And as of now, PHP is around 16 to 20 times more popular, where popular is in quotes because it's hard to actually quantify popularity. But we talk about the PYPL index in terms of number of lines of code or experts, and as well as GitHub repositories sorted by the language search query. And with this, basically, there are 30,000, at least 30,000 of Lua-based GitHub repositories, which amounts to a pretty high number of Lua code lines. And we also know that there's several millions of ESP8266, for example, IoT, very low-cost devices, which unsurprisingly support Lua-based firmwares in the form of Node Lua or Node MCU. So basically, they can run Lua-based programs and, of course, can have vulnerabilities. And there are also a huge number of other devices which are not so visible as ESP8266, but which also have Lua support or Lua-based APIs. And besides that, there are some very notorious uses of Lua to motivate further our work. Is that, for example, there are big web-facing projects such as Wikipedia, GitHub, and Cloudflare, which use Lua in parts of their web-facing projects to serve web pages, dynamically and templated web pages. There are also very well-known tools and projects using Lua as a backend engine or Lua as a graphical user interface template engines such as Nmap, Wireshark, and OpenWRT. Very preeminent projects. And on the other side of the barricade, there's also the malware, which use Lua very interesting features of low footprint and being dynamic for building conventional malware. And very well-known cases where the Flamer, Evil Bunny, and most recently Project Sauron, which contained highly sophisticated Lua code samples. And there are also IoT-specific malware, such as LuaBot. Again, might have vulnerabilities which can be abused or used to take over the botnets. And on top of this, there are incredible amount of other important but less known projects, basically which span any area of technology. But most preeminently, what we are interested in is the IoT, the home automation, the SCADA ICS systems, automotive, for example, in Mercedes-Benz, and various other wireless and mobile chipsets. However, with all these context, with many Lua code repositories and many devices which are Lua-based or Lua-ready, there are zero non-static analysis for secure testing tools for Lua code analysis, while at the same time, there are many tools and services for other languages, such as Coverity, Veracode, AppScan, CodeClimate, RIPS, which provide support for all the other non-Lua languages. And also, there are zero datasets with intentionally or unintentionally vulnerable Lua samples for experimentation, while at the same time, there are many datasets and projects for other languages, for example, Bugbox, then vulnerable web application, WebGoat, and SQL-Lol, which make language security research and static analysis easier in terms of having ready datasets and common baselines. And finally, there is not much systematic research on Lua security. There is basically the one and only reference from Felipe d'Aragon in 2014. And basically, those are the main motivations behind our work. And in summary, we have three main contributions with this research report. First is develop an open source under Apache 2 license, the first and only static analysis tool for Lua. Also, we build an open source, the first public corpus of synthetic Lua code samples, which can be used for various baselines tests or improving the tools. And we will also create and release the testing setups used in our experiments in form of virtual and reproducible environments, such as background images, which can be easily reproduced. In terms of implementation and examples and results, our tool is available at lua.re webpage. You can download the current proof of concept there. It is basically based on an NTLR4-based Python parser, and the parser is generated based on Lua G4 example grammar, which was written in 2013 and 2016, and is available in NTLR's grammars repository. The tool also features built-in tests which can be used to validate or do regression testing on the tools while it's being developed or improved. And this can be found in the test repositories. And we developed also a very, not very sophisticated own Python-based taint engine, which can be found in the taint directory of the tool. And basically, we also tried to implement into this tainting engine some flexible configuration and flexible taint rules where we can specify various syntax tree nodes to be alpha taint sensitive things. For example, IO write, which could result into an XSS. We could have to annotate a particular syntax tree node with taint unsanitizer, for example, HTML unescape, or 10 sanitizers for HTML entities. Just a small note, HTML unescape and HTML entities in this case are kind of ported from PHP. They are not native to Lua, but they're here to make a common ground with existing PHP tools to make it more visible. And there are also taint propagation and pass-through nodes such as string cut or the concatenate operator. And we also feature some combination of the above in case there are more complex functions which exhibit at the same time multiple properties such as being sensitive sync, a propagator, and a sanitizer. For example, a fake string cut print will open. Again, you can see this in the code's source tree. In our experiments, while we didn't have very sophisticated test cases, we used simple yet quite representative synthetic test cases. The tool detects all the simple synthetic true positive test cases and avoids all the simple synthetic false positive test cases. And I encourage you to check the test for various tests and the LangSec 17.py tests. And also, our tool is able to work on quite simple but real old code, such as the CVE 2014-4329, which is a CVE related to N, top, and G. Basically, is a network top tool, new generation. And it provides a graphical user interface written in Lua. So the CVE originally says that there is a cross-site scripting vulnerability in the host details via the host parameter. However, our tool, for example, could find that there is also the page parameter is also vulnerable to XSS, as you can see, for example, in on the right hand of the screen. And this is basically the original source code. You can see that there is a get page parameter which goes into page variable, and then print page will result into XSS. So with such a tool, we could actually improve the existing CVEs or use it to uncover new CVEs in existing Lua code base. So to conclude, Lua is a powerful and performant dynamic language. Its popularity is on the rise, and it's especially on the rise with ESP8266, similar kinds of IoT applications, because of its very small footprint and very very feature-rich language. But there's obvious lack of both static analysis tools for Lua code and corpora of vulnerable Lua code samples. And to conclude, we bridge this gap by open sourcing our Lua static analysis tool and vulnerable code samples. And as future work, of course, we need to dramatically improve the performance of the tool and of the taint engine. There is also some need to improve the parsers and lexer, which is actually not part of our tool, but apparently it fails to parse some real code snippets. And of course, add some of the missing features because now is the first iteration of the tool. And potentially try to improve the taint engine and interface with more generic Yarn engine or more generic configurable taint engines. And before I go to QA, I would like to acknowledge NLNet Foundation and Binary Analysis Toolkit project for their support with this project, Mikkel Linars, Armin Hemmel, and of course all the LangSec reviewers, shepherds, and organizers. Thank you. And with this, I conclude, and I'm ready for Q&A. Thank you.
Questions, please. No questions? Oh, yes, there is a question.
So what kind of analysis can your tool perform? Is it only taint tracking?
Yeah, basically, for now, we do only taint propagation. We use the abstract syntax tree produced by NTLR4 parser. And we basically do very unsophisticated, but what is the state-of-the-art taint propagation. Yeah, I'm not sure if it answers your question, but yeah, basically we don't do any other specific static analysis, let's say.
So let's thank the speaker again.
Okay, thank you very much.